Welcome to my talk, CTAP 2.1, FIDO's new tricks for Passkeys on security keys. Thanks for hanging in till the end of the conference and not running through to a TSA checkpoint to get home. I know that's like my biggest competition this morning. So, who am I? My name is Will Smart. I currently work at Yubico as a senior solutions architect. And I previously worked at a U.S. national lab. So we had all of the identity problems of a federal agency, an educational institution, and a private corporation sort of all rolled into one. And everything was smart cards, right? Smart cards were king. So since coming to Yubico, I've learned quite a bit more about FIDO 2. And FIDO 2 is sort of a breath of fresh air compared to smart cards. The standard is still evolving, which is what we're going to be talking about today. And we are expanding the passkey use cases. So CTAP 2.0, or I'm sorry, CTAP 2.1 was published all the way back in the summer of 2022. And it set the stage for these enhancements to passkeys on security keys before the term passkey, right, even really existed. And it's the first major update to the FIDO standard since 2018. It contains a number of features focused on making security keys easier to use for both organizations and individuals that either can't or just won't adopt sync passkeys. So since 2018, everyone, security key vendors, operating system and browser vendors have all been incorporating these features into their products. And we're at a point now, which is really perfect, where you can get this stuff off the shelf. You don't need a beta product. You don't need to be turning on experimental flags in your browser. You don't need to be running a preview operating system. These things all exist. But that doesn't really mean you can go out and use them today. The ecosystem still needs to be built up around these things. It sort of means it works. So this is the perfect time to start talking about them because these features will need to be fleshed out over the coming months and years. So just some quick notes on terminology here. I'm going to go through these terms real quick and sort of how they relate. This probably is going to be old hat to everyone here because of the number of passkey sessions. But FIDO is just a set of open standards that includes both CTAP and WebAuthn. A passkey is a password replacement based on WebAuthn, keeping it real simple. Those can be stored on security keys, which is a small device that uses typically USB or NFC to store some sort of asymmetric secret, right? CTAP is how those security keys talk to your client or web browser. And WebAuthn is how that client or web browser talks to the server or the relying party or the identity provider. I will probably just say relying party or RP. And then in order to make sure we get through all of this stuff in time, I'm just going to ask that everyone hold questions about like the individual features. I've got some breaks in the slides. Right? And then the last thing to say here is that this is about the web use cases. So right now we're not really aware of any like native software that's taking advantage of these features, but that can change rapidly, right? Someone just has to publish an app, right? So we're going to talk about CTAP 2.1, and we're going to talk about these features, and we're going to show some nutritional facts on here. And I have this on every slide with all the features so that you can see sort of who a feature is for, what the feature is for, right? What does it help? What happens when you try and use this feature and it's not supported? and then whether the relying party actually needs to support it at all, right? Whether you get this for free with the security key and platform support, or whether your identity provider needs to go and make some changes. Right, and then on the right side, we're going to show some information about where it does work right now. When the feature is important, some of these things only kick in during registration or authentication. And then sort of where you can find additional information about it and where you can test it. So if you have a security key from a vendor that has CTAP 2.1 features, where you can actually go to see these things in use for yourself. All right. So we're going to start with the new stuff in CTAP 2.1. The first couple of features we're going to talk about are PIN related. The first of these is PIN change on first use. And this should be familiar to anyone that has a password-based system where you issue a password, and then you can require that that's changed the first time a user uses it. This is going to help with enroll on behalf of and scenarios like that, or any other scenario where you have an agent that is enrolling a credential on an authenticator, on a security key. So you can also do things like enroll a credential and then ship a security key to someone, right? This is like what happens with debit cards right now. Your bank enrolls that credential, they ship it to you, they separately communicate the PIN number, and now you can log in, right? Or spend money. What's the difference? So now you can have some sort of assisted registration flow as well. So if you have VIP users, or if you have a help desk where you can help people along, they can work, the end user can leave whatever that situation is with their security key all set up, so they don't have to do any sort of self-service registration. Right, and then we don't actually need the relying party to do anything here. This is all between the security key and the platform. So you can turn on PIN change on first use and go to any website that uses WebAuthn, and as long as it works on the platform, it'll be supported. All right, the next PIN-related feature we have is minimum PIN length. And this is going to allow organizations more flexibility than just living with the FIDO standard of 4 digits for a PIN. So this provides both a method to set the minimum PIN length, and then for trusted relying parties only to read that minimum PIN length back during registration. And because this minimum PIN length can never actually be decreased, it's sort of a ratcheting function. The only way the end user can set a shorter PIN is if they reset the device. If they reset the device, they've destroyed all of those credentials that they made with the old minimum PIN length. So you can be sure as a relying party that once they've registered, yeah, the PIN is never going to be shorter than the minimum PIN length that you got during registration. Right? The bad news here is that the user experience for minimum PIN length isn't there yet. If you're really lucky and on Chrome, on a non-Windows platform, you will get a very specific error message. On Windows, it's just sort of a, hey, can you try a more complex PIN? So this is one of those things where probably if you're an early adopter, you're going to have to communicate more about that to your end users. And now we're done with the PIN-related features, and we're going to move on to enterprise attestation. So I don't know if you caught Danny's talk yesterday, talked a little bit about attestation. Enterprise attestation is a variant of the typical FIDO direct attestation, and it supports allowing specific, trusted relying parties to retrieve some sort of unique identifier from the security key. This is usually like a serial number, right? So what this is going to do is allow organizations to have asset management over these devices, to have an assurance that not only are you using a device that's from a specific manufacturer and has a specific set of capabilities, but it's one of the devices that you purchased for your employee, and you know the serial number, right? It's in a serial number range that you know that should be being used to access your systems. Right now, this is only on Chromium-based browsers, right? Chrome and Edge. And right now, the situation with enterprise attestation regarding support is that when it doesn't work, it falls back to a normal attestation. So you're not really any worse off than you were before. You just may not get that unique identifying information if you're not on a supported platform or browser. So next up, we're going to talk about some blob storage features. And in the FIDO context, a blob is just any data that's stored with the credential that the security key or authenticator doesn't process at all, right? It's totally opaque to the authenticator. So large blob storage provides they say large, 1 to 4K pool of storage that can be used, and it's shared between all of the credentials that are stored on that security key. So the key will manage generating and communicating with the client a symmetric encryption key for that data so that that client can decrypt that large blob and get at the contents. And typically, this is used for things like SSH certificates, right? If you're working on infrastructure and you need employees to move around from system to system, and you don't want to have to pull those SSH certs in, maybe copy them to systems or retrieve them from some sort of online registry or something, you can actually store that certificate information on the security key with the FIDO 2 credential that they're using for SSH. Right? And then the next feature is credential blob storage. And this is significantly smaller. This tends to be multiples of 32 bytes. And you can only store, there's a limited number of space, but it's per credential, per passkey stored on the device. You can put anything you want if you can fit it in 32 to 128 bytes of storage. But most commonly, this is used for, or the intended purpose, to be used for public key hashes, so that you can, offline or on the client, make a decision about a trusted CA from data that's stored with the credential. This is unencrypted. It can be retrieved by anyone with the PIN. So you don't want to store like PII in there or anything. But if you want to pack some flags about the credential state, there's a fine way to do it. And then the last new feature we're going to talk about is called always UV, right? Or always require user verification. And there was a talk on Tuesday about user verification with passkeys. And this is a feature where either an organization or an individual can say, hey, any authentication, any cryptographic operation with this security key, you have to require user verification. So this is an alternative to the relying party asking for this information, right? This is the key itself saying, nope, I'm not going to sign anything unless I know it's you, unless I know it's an authorized user, right? This will help with things like FIPS 143, which requires that every cryptographic operation coming out of an authenticator is protected by a PIN. And the bad news here, or good news, depending on how you're looking at it, is that if the client doesn't support it, it will fail secure. So it's never going to allow an authentication or registration to proceed without that PIN, which means if the client doesn't support it and the relying party doesn't ask for it, like if it's a WebAuthn as MFA sort of scenario, right? WebAuthn is a second factor. You can run into a situation where you're never actually presented the opportunity to enter that PIN and the operation just fails. Right? I'll point out some good news here, which is that this is one of the few features that's well supported on mobile operating systems. Right? Both Android and iOS support this very well. Windows 11, Chromium again on macOS and Linux. So I wanted to take a pause right here before we go on and talk about some old new features to just see if anyone had any questions about the new stuff. No, everyone's still like processing. All right. Yeah. What's that?
There's a lot of links we can use from.
Yeah. I mean, I displayed a lot of information on the screen. Definitely take a look at the slides after. Yep, you had a question.
So on the always require user verification, it sounds like that's something that the user can control, like on the credential itself, right?
So if it's a sort of consumer-oriented device, the user can flip that on and off. So I can say, hey, I'm traveling with my security key. I don't want this to be used for a second factor if I, leave it in the airplane, right? So I can make that decision as a consumer if it's a consumer-grade key. Some security key manufacturers will let you essentially force that bit on all the time at the factory, right? So that could be your organization's decision on your user's behalf, right? All right, we're going to move on. So these features may seem sort of old hat, but these were technically not finalized until CTAP 2.1. And the first one up is credential management. So this has been around for a long time in some sort of preview. And this allows users to individually list and delete passkeys, discoverable credentials, on their security key. Really notably here, there's no native way to do this in Windows 10 or 11. And to do it in Windows 10 or 11, you need a third-party app, right? And you need to elevate to administrator. So this is very tough to do on Windows. But this is sort of critical if you have an authenticator that can store hundreds of passkeys. Because let's say you enroll a test account or enroll too many accounts or have an account that you don't use anymore. The only way to get rid of something like that is to delete all of the passkeys on the authenticator and then start reloading them from scratch, right, by resetting the device, unless you have credential management, and you can do that. Right, and the last thing we'll talk about is biometric enrollment. Biometric enrollment was in the spec pretty early as a preview, so it actually does have support on Windows 10, which is great. No mobile support, unfortunately. But this is just the ability to manage whatever the biometric is, usually fingerprints, on a security key, without having to use a vendor's utility. Right, so this is a vendor-agnostic, open standards way, so that no matter what you plug your security key into, you can start that enrollment process and get started with your biometric enrollment. You don't have to download anything. it's sort of important to have this on a platform so that you can do this sort of high security thing, something that users typically want to see a little bit more trust for, maybe more wary about doing, without leaving the comfort of either your operating system or your browser's like trusted settings panel, right? You're more likely to do something maybe involving biometrics if it's a Windows setting versus some like pop-up window on a website maybe, right? So. And then, so that's it. But I'm kind of going to start with a question that I'm going to ask you, which is, what problem have you had with security keys that we didn't really talk about today? All right. I'm just going to flip back here. Nope. Right there. Yes? What about using biometrics instead of a PIN? Using biometrics instead of a PIN on a device is very tricky because there are all sorts of reasons that biometrics can fail. Anything from hygiene issues like you just ate a sandwich, to you're wearing PPE, to the humidity is wrong, right? So we sort of the FIDO Alliance, and actually I think individual security key manufacturers can make their own decisions on this, but some of the manufacturers view biometrics as a convenience feature and not really a security feature, right? So it is convenient for when you can use it, but you always have to rely and know that PIN. And that's very similar to the situation with smartphones today, right? You have your Face ID, you have your fingerprint unlock, but you always have to enter that PIN in the first time the device boots up. Right. Yes?
More of a comment than a question, but if you use a pure hardware token, not a platform one,
Yep.
it's often recommended to have a second one.
Sure.
It's lost or run over or whatever. The discoverability aspect can help you manage. Did I get that same? Did I enroll the other token for this site?
Yep. So I'll just repeat that for everyone because it's not mic'd. So it was when you have two hardware security keys, right? Because the recommended best practice when you're using hardware security keys and you actually want recoverability is to just have two. And discoverable credentials, which is what most people think of as passkeys, can help with that because you can just plug the thing into your computer and get a list through that credential management interface of exactly what credentials you have stored on there. So you can go, oh yeah, okay, my Microsoft account or whatever is definitely on this key. I'm just going to throw it in my safe and be done with it, right? So you can have that sort of assurance that like, oh yeah, this is the key with that account on it. Yes, in the back.
You started off by saying this is like a breath of fresh air compared to the other credit cards and
Yeah.
what are the headlines as to why this is better?
So it's a breath of fresh air because this standard moves. It moves fast, and it's a consensus standard, right? This is an industry consensus standard. PIV is great. It is stable. It hasn't changed much. So, if PIV had really, I've been using PIV since 2016, right? So if PIV was going to be the thing that was going to get adopted everywhere, it's had the time, right? I don't think it's going to happen. Whereas Passkeys and FIDO 2 is making great strides. It's moving very quickly. So it may be sometimes more like a tornado, or a hurricane than a breath of fresh air, but at least we're seeing some movement, right? All right. Any other questions? Oh, yeah.
Sorry, I just wanted, going back to the always UV thing. So
Yeah.
I, in the consumer space, not
Yep.
so I, as an end user, can, when reading the Passkeys, for example, say always perform UV, and that's, persisted as a part of that passkey. So then when a relying party triggers the authenticator, I understand that the UV should happen, but I don't understand the unsupported client piece, because if it's at the authenticator level, does this mean that there's something that needs to go into WebAuthn to support this, or how?
No, so it's already in WebAuthn. So the question was, if the authenticator enforces always UV, how do you ensure, or what is missing, right, when an RP requests an authentication, and why might it fail, right? So it will fail if, for example, you're signing into a flow that uses a WebAuthn credential as a second factor. So you've put in your username, you've put in your password, and now you're doing WebAuthn as a second factor. The browser doesn't expect, because the relying party has said, hey, this is WebAuthn as a second factor, I'm going to say UV discouraged, right? This is how I've always done it as a relying party. That really doesn't change anything. So once you do that, the browser gets that WebAuthn call, and then it goes out to the security key, and it skips the part where it says, hey, what's your PIN? I need to tell that to the security key. So you as the end user are never prompted with an opportunity to put in that PIN. So that gets passed to the security key. Security key says, nope, try again, right? Because this is something that the browser would expect to work with CTAP 2.0 all the time, right? Because this wasn't a concept. And then you end up with an unsuccessful operation, right? Either registration or authentication. Does that make sense? Yeah. Fun fact is, if you use biometrics, if you use something that has a built-in user verification, it sort of skips all that, right? Because the browser never has to tell the security key what you, the end user, typed in. Right. I think we're at time here. So please feel free to reach out, get in touch. If you have any questions about this stuff, I kind of love talking about it. And yeah, I think that's it.